Hello viewers, in this session we just discuss some examples on methods of differentiation. The methods that we are going to consider are the use of logarithms, the quotient rule, the chain rule, and the product rule. So we start with differentiation using the method of logarithms, what we call the logarithmic differentiation. So here we look at the use of logarithms or the application of logarithms to solve some problems of differentiation. So we start with stating the rules of logarithms as may apply to functions. So we have three rules of logarithms. Rules of logarithms applied to functions. So we consider some two functions. So suppose that f of x and g of x are two functions of x. Then we can state the rules of logarithms as follows. The rule number one, we shall state them in the order that we usually apply them. So we have the logarithm, that is the natural logarithm of f of x divided by g of x is equals to the logarithm of the function f of x minus the logarithm of g of x. And number two, logarithm of f of x times g of x is equals to the logarithm of f of x plus logarithm of g of x. And lastly, if k is a constant, be a real number, then we have the rule number three, that the logarithm of f of x raised to the power of k is just equals to k times logarithm of f of x. Remember, because we want to deal with the problems of differentiation, then we use the logarithms to base e, or what we call the natural logarithms. Natural logarithms. But remember, the same rules can be applied to logarithm to any other base. So we have the three rules. When we take the logarithm of a quotient, then the result is the same as the logarithm of the numerator minus the logarithm of the denominator. If we take the logarithm of a product, then we take the logarithm of the individual functions, then add them. And lastly, if a function f of x is raised to the power of k, and then we take the logarithm, then k, the power k becomes the coefficient. Now we're going to look at an example. We just do one example. So we want to find dy dx, and you are given the function x cubed plus 1 multiplying e raised to power 4x divided by cosine of 2x. So we want to use these laws to simplify this expression, and then we take then we differentiate. Now, before we go into the process, there is something here that we need to state the rule of differentiation, or the differentiation rule. Let me call it the differentiation rule. That we are going to use. So we have, if we want to differentiate with respect to x, a function which is logarithm of some function of x, then the result is the same as 1 over f of x times the derivative with respect to x of the function f of x. So this is the differentiation rule that we are going to apply. Apart from the three laws of logarithms, then when we get to the differentiation process, then we use this differentiation rule. So we have our function, which is y is equals to x cubed plus 1 multiplying e raised to power 4x divided by cosine of 2x. So the first step when using this method is to take logarithms on both sides of this function. So we take logarithm on the left hand side and take logarithms on the right hand side. X cubed plus 1 e raised to power 4x divided by cosine of 2x. So now we shall apply the rules of logarithms to the right hand side. So say if you look at this expression, you'll notice that the expression inside the brackets here is first a quotient. There is the numerator and the denominator. So by the first law that we stated there, this one can be expressed as the logarithm of the numerator minus the logarithm of the denominator. So we write logarithm of x cubed plus 1 e raised to power 4x, that is the numerator. We subtract logarithm of the denominator, which is cosine of 2x. Now, if you look at the first expression, the first term now, we have a product, x cubed plus 1 multiplying e raised to power 4x. So here, because this one is a product, then we can write this one as the logarithm of the first function plus the logarithm of the second function by using the second law that we stated there. So we write x cubed plus 1 plus logarithm of e raised to power 4x minus logarithm of cosine of 2x. And now the first term is a sum. The expression inside the bracket is a sum. So we do not have any law that can expand the sum from the three that we stated. There is none that can expand the sum. But in the second term, we have the power, e raised to power 4x. So e raised to power 4x, we can apply the third law, which says that the power becomes the coefficient, so that we get logarithm of x cubed plus 1 plus 4x logarithm of e minus logarithm of cosine of 2x. But we can now find the value of logarithm of e. If you use your calculator, you can get this to be equals to 1. So that in this case, we can write logarithm of y is equals to logarithm of x cubed plus 1 plus 4x minus logarithm of cosine of 2x. At this point now we differentiate both sides with respect to x. So we now differentiate both sides with respect to x. So we introduce the operator d by dx on both sides. D by dx of logarithm of y is equals to d by dx of logarithm of x cubed plus 1 plus d by dx of 4x minus d by dx of logarithm of cosine of 2x. So we now use the differentiation rule that we stated, that whenever we have the derivative with respect to x of logarithm of some function, the result is always equals to 1 over f of x d by dx of f of x. If you look at the function we have here on the right hand side, it is of this form where f of x is just equals to y. So that means that we can write 1 over y dy dx. That's the left hand side. 1 over y dy by dx. We are using this rule here. On the right hand side, the first term, the function is x cubed plus 1. So we shall have 1 over x cubed plus 1 d by dx of the same. So 1 all over x cubed plus 1 d by dx of x cubed plus 1. The next term is the derivative of 4x. That one is just equals to 4. Then the last term we have, the function is cosine of 2x. So we have logarithm of cosine of 2x. So if you have here, if you replace f of x here with cosine of 2x, then you get 1 over cosine of 2x d by dx of cosine of 2x. So 1 all over cosine of 2x d by dx of cosine of 2x. So we can now differentiate the first time here we get, if you differentiate x cubed plus 1, we get 3x squared. So that the first term here becomes 3x squared divided by x cubed plus 1. Then we have plus 4, then minus, the derivative of cosine of 2x is minus 2 sine of 2x. So this one is divided by, or is multiplied by this quantity. So we have cosine of 2x. So we get 3x squared divided by x cubed plus 1 plus 4 plus 2 sine of 2x divided by cosine of 2x is the same as tan of 2x. So I'll write tan of 2x, which is sine 2x divided by cosine of 2x. This is 1 all over y. This is the same as 1 over y dy by dx. So to find dy dx, we can now multiply both sides by y, so that dy by dx becomes y. Then we have 3x squared divided by x cubed plus 1 plus 4 plus 2 tan of 2x. Remember the sign here changed because when we differentiate the cosine at this point, we get the negative 2 sine of 2x. So minus minus will give us positive. So this is the derivative dy dx. Of course, we can replace our y with the expression x cubed plus 1 e raised to power 4x divided by cosine of 2x, or we can leave it in this form. So, but I'll just substitute x cubed plus 1 e raised to power 4x divided by cosine of 2x. This is our y. So this multiplies 3x squared divided by x cubed plus 1 plus 4 plus 2 tan of 2x. So this is the derivative dy by dx. So we can replace y, or we can just leave it at this step. There is nothing wrong getting up to that point. So note that the important thing here is to remember to know the laws of logarithms and the order in which you need to apply them. start with a quotient, where there is the logarithm of a quotient. It is the logarithm of the numerator minus the logarithm of the denominator. Then if you have a product, you apply this law. Then where there is a power, the power becomes a coefficient. After you have simplified, like we have done here, take logarithms on both sides. Then remember this differentiation rule for the logarithm of a function. So basically that is the method that we call the logarithmic differentiation. And that is how the method can be applied. Now the second method I want us to look at is the quotient rule. The quotient rule, this one says that if y is equals to u divided by v, where u and v are functions of x, then dy by dx is equals to v times du dx minus u times dv dx divided by the square of v. Notice that u is the numerator function and v is the denominator. So we can apply this rule to differentiate a function. Maybe you are given a function y, say as 2x raised to power 5 minus 8x divided by sine of 3x. And the problem is to find dy dx. You are told to find dy dx. So what is the value, or what is dy dx in this case? We notice that the function given here is a quotient. It can be expressed as y is equals to u divided by v. So u here, the function u is equals to x, or rather 2x raised to power 5 minus 8x, and v is sine of 3x. So we then differentiate u with respect to x, so we find du by dx, which is 10x raised to power 4 minus 8 minus 8. And then we also differentiate y, or rather we differentiate v with respect to x, which will give us 3 cosine of 2x. So now we are going to multiply v with the derivative of u and u with the derivative of v, then subtract. So we write dy by dx is equals to v du by dx minus u dv by dx. The whole of that is divided by the square of v. So in this case, v is the function sine of 3x. So we are going to multiply this by du dx, which is 10x raised to the power of 4 minus 8. Then we subtract u. U here is 2x raised to power 5 minus 8x. And this is multiplied by dv dx. And dv dx is 3 cosine of 3x. Then the whole of this is divided by the square of v, which is sine of 3x raised to the power of 2. So this is the derivative. We can as well leave it in this form, or maybe we can write it in a better way. Dy dx is equals to 10x raised to power 4 minus 8 multiplying sine of 3x, then minus 3 multiplying 2x raised to power 5 minus 8x multiplying cosine of 3x divided by the square of sine of 3x. So this is the derivative, dy by dx. So notice that u is the numerator, v is the denominator. We differentiate u with respect to x. We also differentiate v with respect to x. Then we multiply v with the derivative of u and u with the derivative of v. The second method, the next method is the product rule. The use of the product rule. This one says that if we let y be equals to u times v, then dy by dx is equals to v du by dx plus u dv by dx. So here, u and v are functions of x again. We can do an example. You are given a function y is equals to, say, e raised to power 3x multiplying sine of 2x. And the problem is to find dy dx. So this is a product. This one can be expressed as u times v. So u is e raised to power 3x and v is sine of 2x. So again, we differentiate u with respect to x, and this should give us 3 e raised to power 3x. We also differentiate v with respect to x, which will give us 2 cosine of 2x. Again, now we shall multiply v with the derivative of u and u with the derivative of v. So dy by dx, but this time remember we are adding. So when we multiply sine of 2x by this, we get 3 e raised to power 3x multiplying sine of 2x. We add 2 u times dv dx. So e raised to power 3x multiplying 2 cos 2x. So we get 2 e raised to power 3x times cosine of 2x, which is the derivative dy by dx. The use of the product rule. That is the product rule. So the product rule says that if y is a product of two functions, u and v, then dy dx is obtained by first differentiating the individual functions, u and v. So you get du dx and dv dx. Then multiply u with the derivative of v and v with the derivative of u, then add the results. The last method that we're going to consider here is the chain rule. This one says that if y is a function of u, where u is a function of x, u is a function of x, then dy by dx can be expressed as dy by du times du by dx. dy dx is equals to dy du times du dx. This method is called the chain rule. And we are going to do an example. So we take an example. Say you are given a function y is equals to cosine of 3x raised to power 4 minus 7x squared. This is 3x raised to the power of 4 minus 7x squared. So here we want to find dy by dx again. So we can start by setting u. If we let u to be 3x raised to power 4 minus 7x squared, then y becomes cosine of u. So we can now differentiate y with respect to u. and x and u with respect to x. So we can find dy by du, because now y is a function of u from here, which will give us minus sine of u. We can also find du by dx by differentiating this expression here, which will give us 12 x raised to power 3 minus 14x. So once we have this, then dy by dx using the chain rule is equals to dy by du times du by dx. So we just multiply these two. So we have minus sine of u times 12x raised to power 3 minus 14x. So we can write this one as minus 12x raised to power 3 plus 14x multiplying sine of u. But now what was u? The function u, we had it up here. U was 3x raised to power 4 minus 7x squared. So we can substitute back here, and the result will be minus 12x raised to power 3 plus 14x multiplying sine of 3x raised to the power of 4 minus 7x squared, which is the derivative dy by dx. This method is what we call the chain rule. The chain rule is a method of differentiation called the chain rule. Notice how the sign changed here. Notice how the sign changed here. Because we have a negative sign u, so if we push the negative here, then this term becomes negative, this becomes positive. That is how we ended up with minus 12x cubed plus 14x. So this method of differentiation, we call it the chain rule. So those are the four methods that maybe we can use to differentiate functions where we have product, the quotient, or even the composite function. But remember, the method of logarithms can be used to differentiate the cases where we have a more complex function. So thank you for watching, and hope this will be helpful.